Welcome everyone, thanks for coming. Well, we didn't get as many that booked, but at least you all got seats, which you've got to look at the pluses, right? Thank you for coming, and it's my pleasure tonight to introduce Jay Yang. He's a blockchain engineer at MetalPay, and he's going to actually answer all your questions, well, hopefully most of them, tonight on the blockchain and cryptocurrencies. So there you go, Jay. Welcome, Jay. Thank you.
Hello, everybody. How's everybody doing?
Yeah.
All right. Okay. So, who here owns cryptocurrency? All right. Most of you. Who here writes software for a living? All right. A third. So there's a good number of people here. Who's brand new to cryptocurrency? All right, so 10%, 20%. Okay, so I'm going to go through a different aspect, or normally the presentations focus on things like the philosophy, the what it enables, what the future is, and all of that. I'm going to just take a step back and say, okay, you bought a new car. You have no problem driving it, but you want to pop the trunk. At least get a look at what it is in there. You don't want to see like a gremlins or things like that running around. So we're going to move on from there. So Satoshi Nakamoto in his groundbreaking paper basically laid out a way to transact without trust. And we'll cover that as we move on. So let's say you're designing a currency or a clearing system for currency. Let's say you have to answer all these questions where how do you keep track of who owns what? How do you prevent others from spending your money? How do you prevent forgery? How do you make sure that other people know that you received the money that someone else told them that they sent? So you have to kind of answer this, and if it's a centralized system, it's easy to say. Like you just go to a bank and you say, okay, well, I trust the bank to handle all my balances correctly, and I send somebody some check and they cleared it and we're done, right? In the electronic world, similarly, you can just do it in a centralized location, like a database, or you make some API calls and you're done. But it's not so easy when you try to decentralize it and remove a layer of a control that's normally there. So most cryptocurrencies have these elements right now. So in the future, who knows what kind of incredible technology we'll see, but at the very least, there are some elements that roughly map to this. Transaction entry, because you need to know you send what amount to whom. And you need public addresses because you need to send the amount, and private keys because you need to sign it. You need history of transactions. You need to understand what happened prior to your, acquiring the cash. And then some sort of consensus algorithm. And when we say consensus algorithm, that term gets thrown around a lot. It basically means we need to agree on something because there's history, there's a lot of things that are built into it. Everybody has to agree on it, otherwise the whole system falls apart. There's no faith, and there's nothing works. And most cryptocurrencies have some sort of economic reward system. And what that means is, we'll cover that in a little bit of detail, but it basically prevents malicious actors from taking over the system. So think about email. You have gazillion email, and you have infinite email addresses, right? So you have, what kind of problem do you have? Spam, right? So anybody can create an email address, and they can send the spam email and just clog up the system and make your life just a little less enjoyable. How are these things used, though? Like in designing a cryptocurrency system. So this is relatively new concept. So Satoshi Nakamoto in his paper basically rolled together a lot of work that's gone prior to his writing this into a single application. So he basically said, all right, if I wanted to make a currency that is decentralized and resides in a public ledger, how would I go about doing it? So we're going to call this Nakamoto consensus. I'm not the first one to call it that, so please. So there has to be some rule, right? If I'm sending you money, or you're sending me money, or there's some sort of system, there's always have to be a rule. And we have some sort of protocol, and that is anyone can send transaction records. So I can send to you a transaction record, you can send me, and anybody can look at it. All transactions are signed. So this answers the question of, okay, well, how do we know the origin, right? So there has to be some sort of proof that you're the person who signed it, you're the person who sent the transaction. No one can overspend, and this is groundbreaking, of course, as we know, but very important. So you can't have negative balance. The reward the work that's put into validating transactions. And these two actually are important aspect of cryptocurrency, or at least the Nakamoto consensus. And what that enables us to do is to create a system under which no trust is required in order to transact and send people money and make sure that those money that are sent are valid, and you can prove that it's valid. But why? Why do we need to reward the work? Why do we need to validate the transactions? Why do we need to adopt the longest history of post computation? What does that even mean? So we'll go over that. So you hear this a lot, something called a proof of work. And what that means basically is that you solved a very hard math problem. And every cryptocurrency, almost every one of them, have some sort of variations of this, where you collect a set of transaction records, and then you try to guess the result for which it has a certain very validatable result. So for example, when you run this problem through and you have some desired result, and the input that was guessed in order to get to that desirable result is called proof of work. And all it means is you spend a lot of electricity to validate all those transactions. And proof of work basically assumes everybody's hostile. You're trying to steal from me, he's trying to steal from you, everybody's trying to game the system, and so no one gets to go scot-free. But what it does is it increases the cost of attack. So think about if you go to a coffee shop or Starbucks or whatever, and you try to log into some website, every once in a while you'll see CAPTCHA, right? Which is like, you click on all these street signs and all that stuff. And what that's trying to do is delay the time or increase the cost of you trying to log in. Or in this case, they don't know that you're not you, and therefore they have to increase the cost of logging in order to make sure that only the people who are patient enough and people who are honest enough actually get to log into their website. So proof of work, by solving a very hard problem, increases the cost of attack. And I'll get to that in detail. And proof of work confers no special status to nodes. What that means is that, let's say you're a bank. You have special status. You can write and make changes to everybody else's balance. Sometimes, of course, it's illegal, but you can because you're in a position of privilege and power. But by having this system, it confers no special status to nodes. And all that means nodes are you, people who are mining, the wallets, whatever else. So what is this exactly? The technical term is cryptographic hash of a digest. And digest is just a collection of records, transaction records. And so you mash the transaction records together, ordering it in time, and then you run it through a function, and then the function creates some sort of a result, which is more or less irreversible. So you can take the results from the function to guess at what was there. And proof of work requires that there's some pattern to that result in order for it to be a valid block. I'll get to that more in detail. If it doesn't make sense, you'll have plenty of time. It'll be an AMA, so you'll have plenty of time to ask questions. And I promise you, you'll be better for it. And I'm going to throw a bunch of terms at you, and I'll try to explain it. So what does Byzantine fault tolerant even mean? You hear it every once in a while. Like, what does it even mean? What it means is this. When do we decide to move ahead with a course of action or change of state. So meaning like, let's say I want to go to dinner party, right, with you, and you send me a letter and say, let's go to dinner party. I said, okay when? And going back and forth, and it's just never-ending cycle of email or letter. When do we exactly determine when to decide a course of action? And that's part of the Byzantine fault tolerance, but it also has to do with there are different classes of Byzantine generals problem where you don't know the origin of the message, you don't know who agreed to what. So for an example, I can send, maybe there's a committee of 9 people, and they all have to, at some point, majority has to agree, or all of them have to agree in order to enact some course of action. When do they decide enough is enough, let's just move on? It's kind of like electing a pope, right? So moving on. So we have, what does civil attack resistant mean? So civil attack is basically you have a bunch of sock puppets or automated accounts or malicious actors in the system that wants to just make your life miserable by spamming the system, by sending out malicious records or orders or operations or whatever. So think of them as spammers. And what that means is in the context of currency, in the trustless public ledger, and because anybody can send transaction records over the wire, what that means is that I can send a quote-unquote forged record of me transacting with somebody there, right? And then say, well, he gave me some money. I should have some money, right? That doesn't quite work. And the reason why it doesn't work is because Satoshi Nakamoto had an incredible insight and came up with a very elegant solution, which is the reason why a lot of these email spam attacks continue to be a problem is because it costs them nothing, next to nothing. I mean, like, they just write a bot and they just continue to send millions and millions of spam mails. And you have an infinite number of email addresses. So there's no way to stop this. So the burden has to be on people who are filtering it. But what if you made each of the transaction or the effort of sending a costly one, and that you have some incentive to make sure that only the honest actors continue to act honestly, and they outnumber the malicious ones. So that's the crucial insight. And of course, like, you can't have the system if your transactions are all forced, right? Or you can just write a bunch of nonsense and it makes no difference. So the cryptocurrency has to be tamper evident. If somebody sent some kind of transaction record and I didn't sign it, that doesn't belong to me, that's your problem. So that's the tamper evident part of it. And there are other finer points that make certain cryptocurrencies able to resist attacks and be trustworthy, even though you assume no trust. So Satoshi Nakamoto said this with respect to trying to write for a broadly read publication, and basically I think it was Gizmodo. If I have this incorrect, please let me know. And he said it's bloody impossible. And the reason for it is because people have this notion, or at least they were born with it, they were educated with this notion of money, and because it's so seamless for the most period until there's some crisis, that you don't necessarily think about what's the fundamental problem. Why are these problems even a thing? But when you flip it on its head and say, well, let's assume everybody's a bandit and we try to design a system, then we get something like this. So this is my poor attempt at trying to describe step by step what happens in Bitcoin network. And Bitcoin network is important because it's sort of where everything started, and it's the reason why you're here if you want to learn more about it. And so node creates and signs a transaction. So that's the first step. Second, node broadcasts the transaction to the network. It just says, hey everybody, I'm sending somebody money, and I signed it. And then other nodes listen and for new transaction, records that are being broadcasted. And what happens after is that some nodes collect these transaction records that are being broadcasted and mashes it into block. And they solve for a very specific problem, and then they, at the very end of the block, they say, this is the proof of work. I spent this much computational cycle to solve this problem, and here's my claim to reward. And the proof of work is important because it's actually used later on when you link the blocks together and say, okay, well, this is how, it's kind of like a ancient Babylonian epic where you go from one chapter to another and it's like a continuous story, and there's a reason why it goes from one to another. So there's a continuation. And node broadcasts a new block. So I'm saying, like, here's my lottery ticket. I sold it, and they broadcast the solution and say somebody has to verify it. And when somebody verifies it, they basically get to claim their reward. And that's pretty much it. And your nodes, your wallets, the full nodes, they have a right to download all of the transaction from time zero, a Genesis block. And then you can actually go through and validate all of the transactions by looking at the proof of work and say, okay, are these ordered properly? And assuming that they're ordered properly, are all the records in line? And that when you tally up all the records, some people should have 10,000 or a million bitcoins. Other people should have 0.01. So that's very important. So that's the step-by-step.
Question?
Yes?
What happens when Bitcoin reaches 21 million? So does the reward just disappears and everything else still stays sustained?
Yeah, so when it reaches 21 million, so it's a gradual process. So there's a growth rate that decreases over time. So you continue to get rewards, but it halves every few years or whatever it is. I don't remember exactly. But when it halves, you still get the reward, but the notion is, or the hope is that the fees will be high enough that the miners will be continue to incentivize to secure the network. So that's one. And two, I know what you're going to ask. So two, is that enough? Are fees enough? No. So it's possible that large organizations like vendors that rely on Bitcoin network to be secure may actually run full nodes, and they may actually run their own mining networks, so that hey, I have vested interest in securing the network. Doesn't matter if I make a whole lot of money from it. So I'm just going to run a bunch of compute nodes to validate the transactions, and that's exactly it. By the way, that's what started to happen. So I'm going to go over some other aspect. By the way, I'm sorry. I stopped you. Go ahead. Ask your question, please.
You're good. So is it not inherent in like how Bitcoin functions and cryptos in general function that the people who are mining these, as the cap gets larger, their incentive to mine gets smaller?
It's possible, but as we've seen so far, that doesn't seem to be the case. It seems like the miners continue to mine and they continue to claim rewards because it's still worth it for them at some point, right? If the electricity cost is zero, then it's free money for them. But in some places, electricity cost is very low, and other places is very high. So that's one way to look at it. There are other ways to handle this, right? So the proof of work is just one way, which is that you assume everybody hustle and that you need them to perform some work in order for them to verify that they're an honest broker and that they're not going to just compute for the sake of computing. So there's an alternative system called proof of stake, and it assumes some responsible party. So it basically says, all right, I own 1 billion, J block, and that everybody else owns, 200,000 J block, and so I should, because I have such an enormous economic incentive that I should act responsibly. And of course, I'm just going to leave it up to you to determine whether that's a good idea or a bad idea. So we'll just go from there. So in proof of stake system, you basically say, all right, look, if you own more than a certain number of coins or tokens, you're a big player, and therefore you should run. You should be a part of the system that determines what. How the transactions are validated and so on and so forth. And if you do that, then suddenly the computational cost goes down because you have a limited number of people that needs to all agree in order for a block of transactions to go through. And that's more or less how banks work, right? Like interbank exchange and all of that, right? So it's nothing new. So I might be grossly missing the point. So if I am, please raise your hand. Next thing is, of course, it confers some special status, and there's a lot of coins that have proof of stake as a model, or at least they claim that they're going to have, or they're going to migrate over to. There are some ways to ensure honest brokers come out on top, but I'll just leave it up to you to determine how that's possible.
Sorry.
Yes.
So on the proof of stake, so I think Ethereum is proof of stake, if I'm not mistaken.
Ethereum is trying to get to that point.
Okay.
So yeah, go ahead.
But then so practically, so with Bitcoin, you've got all these distributed miners, thousands of them fighting for the first.
Yep.
So just practically, how would this happen? It would be, let's say, like 5 players that do the whole. Is it less?
So it really depends. So
questions back before you go.
yeah, of course, yeah. The question was, so let's say you have a proof of work system. So some cryptocurrency that uses proof of work, and now you decide, okay, well, at some point after this block, we want to go to proof of stake. How does that work? So there are variations of the theme, but it basically works like this. They'll basically have to, do a hard fork. And what hard fork means is that at some point after this block, this old chain, we're not going to support it anymore. It's kind of like old software. We're not going to support it, and we're just going to move on, and we're going to use a different way to handle transaction clearance. And what that means is, all right, so are there going to be 5 players? Maybe. It really depends on what kind of threshold they want to use to determine whether you're a responsible party. So it really depends on how the code is written and how they want to sort of like bring into the fold the various people in order for them to be responsible. So it could be 1 million, it could be 10%, it could be 5%. Really depends on the cryptocurrency. And we highly encourage you to kind of go through how different cryptocurrencies intend on migrating over or intend on rewarding people who have locked. Yes, thank you.
Oh, so like there's Neo, and Neo's like doing it differently.
Sure.
It's kind of weird. Like I don't really understand. They're doing it so they're just giving the nodes away to organizations that they feel like have the best interests for the currency.
Right. So what they're doing in Neo's case is basically saying, look, if you're a big, financial institute or a big, research firm or IBM, we're just going to give you a node because we know you're a big enough player outside of crypto to, not make a mess of it. Maybe they just don't care. Maybe they're like a absentee landlord that's going to run the node and there's ancillary benefits to doing it. Who knows?
What do you think is the best way?
What do I think? I have no idea. If anybody tells you they know exactly what's the best way to, handle proof of stake, I would love to learn more. So please talk to me afterwards if you do. But I have no idea. So another minor, quip I have is a cryptocurrency does it contain a ledger or is it not a ledger? So Bitcoin doesn't have balance. So each block doesn't have a balance of someone, like meaning that when you send money to me, it doesn't say, well, person sent money to Jay, and therefore this person has this less money, and I have this much more money, and therefore the final balance at that snapshot is, XYZ. It doesn't have that. The Bitcoin doesn't do that. It's just a continuous history of transaction records, and That's it. So it's maybe it's not a ledger. Other cryptocurrencies have balances, so it could be considered a ledger. And if you have a balance assigned to addresses, that allows for calling of the record, right? So you can kind of like take a snapshot and say, well, you can just forget everything that happened before this time and then just move on from there. So there are some benefits and negative points, but if you're talking about something that is worth a lot of money, maybe you do want the full history and not just a snapshot. So, yes?
I have a quick question from the previous slide.
Sure thing.
You're mentioning proof of stake and responsible parties.
Yep.
Am I correct that a master node is the same thing?
Yeah, so I mean, like there are different terms for it. So master node could be one.
Okay.
It really depends on what do they mean by master node. Like, do they mean that the master node is the one that kind of approves the finally commits the transaction record change? Or does it just mean it's just where everybody can send their transaction? It really means different for different cryptocurrencies. Okay. So I kind of started on the how, and now we're at why. So do you care about any of this?
Yes.
Great. Excellent. So we're going to go through each one of them. What does it even mean? Like, why do you say decentralization, and why is it so great? Why is it better versus centralization? What does, what about federation? Why don't we just have a network of people and then kind of believe that those group of people are reasonably safe, and then therefore by association we're going to, What does it matter? And I'll just say some witty things about it, and then we'll talk about it. What does anonymous mean? Like, and when you hear things like, oh, Bitcoin is being used by malicious actors, and you have no idea who's doing what, that's absolutely not true. It's absolutely the other way around. You know exactly who's doing what, how much they're spending, because at some point they want to exfiltrate that money into a real economy. So it's pseudonymous, it's not anonymous. There are some anonymous cryptocurrencies, and we'll cover that a little bit. So backward compatibility, yes?
Well, it's partly true, right? Till they move the money. I mean, no one really knows if Satoshi even exists.
That's true.
They know they have the address and there's 18 million Bitcoin or whatever it's supposed to be.
Yeah.
But it's not moved in 10 years, so we don't know. That's no way to
Right.
identify.
So if the money is immobile, then that's absolutely true. But if you start moving it around, and there are hints of sort of like edges where that money has trailed across a real economy, then you know exactly who it is. You can kind of build a profile of who it is. And you'll start seeing more cases where, there's very sophisticated analysis of just basically understanding, okay, well, these people move money around, and they're basically theirs. And IRS, they'll figure it out, unfortunately. Well, maybe fortunately, I don't know.
Follow-up to that. If Bitcoin doesn't have ledgers, how do they know Satoshi's account has 1 million Bitcoin in it?
So what we do know is that from time zero, there are a series of transactions, right? Let's say I gave you, at time zero, I have there are $100 in system, okay? And we say, okay, you have 50 and I have 50. So that's time one, so we have $50 each. And then at time two, you gave me $5. So even if you just keep track of all the transactions, you can actually get a good history of who has what when you take a snapshot at that time, and that time in point, because transactions are time stamped as well.
You can go to the Genesis block.
Right. Right, exactly. So you can go all the way back and say who has what. Yeah.
Question.
Yes.
Did the Genesis block ever get access? Do we know that?
It's accessed all the time. I mean, in fact, you can go and inspect it, and you can see what it is.
But nobody used the private keys.
So let's think of it this way. Block is time stamped, meaning that it's only meaningful at that particular time. So if I say, well, access the Genesis block, that's not meaningful right now. right? Because it's basically a record keeping of who sent what money to whom. It doesn't say things like, well, here's a pot of money, and you can go grab it. That's not what the block is. A block is basically a record of, I sent this person, $8, and that person gave me $2, and so on and so forth. So it's accessed all the time. You can actually go to Public Blockchain Explorer and then look at from time 0 what has happened. All right, great. So I'm gonna go through 2 more and make funny comments, and then we'll open it up for questions. All right, so this is like wonky stuff, right? Like full backward compatibility. What does that even mean? And versus hard fork. So there are different schools of thoughts in moving cryptocurrencies forward. Meaning that, let's say you're a diehard Bitcoiner from time 0. Wouldn't you want to have your old addresses work, right? So that's what full backward compatibility is. But you can't have an ossified system with security breach, right? So you have to actually, at some point, you may have to do hard fork. What that means is just abandon the old transaction records and rule sets, and then adopt a new one from a snapshot of a block, records or the transaction records. And some cryptocurrencies are notorious for just going nuts with the hard forks. Others are more measured in adoption.
Did Bitcoin have a hard fork before Bitcoin Cash?
So that's a little bit different topic. I'll cover that in a while, but that is a very good question. So which brings us to the next question, which is, when you inspect sort of developer teams' philosophy, you'll get a feeling for what they think is important. And do they want a default state to be safe, or do they want safety to be optional? What that means is that, do I want a car with brakes, or do I want to slow down and do a crazy maneuver in order to, do I want the brakes to be optional? I mean, that's basically it, to grossly simplify it. So there are some cryptocurrencies where they do a hard fork and they just don't care about what happens to the old chain. They don't care about people who have old addresses, whatever. And they have replay attacks, which I'll cover also. And so that's important. That tells you commitment to work, and that tells you how important to developers your money is. So that's very important aspect, often overlooked. The last one is the cryptocurrency. Is it security through design, good design and thought, or forethought, or is it security through obscurity? What that means is basically. To simplify, it's this problem. When you call a credit card company, they're going to ask you a bunch of questions to verify your identity, right? You actually, at some point, have to give them your social security number. Social security number is an example of a identifying information that is only used because of its obscurity. Meaning, I have no idea what everybody's social security number is. Maybe I do, maybe I don't. But that's like the secret number that unlocks your account. But it's not so secret. It's because it's it's just a series of numbers, right? There's nothing inherently safe about it. But if you go to any e-commerce website and you see a little HTTPS, what that's basically saying is all the packets that are going back and forth from your browser is secured by encryption. And let's say I sign an email with a PGP key, and I encrypt it and I send it over to you. You know exactly who it's from without knowing my private key. Sorry. So that's security by design, meaning I can send you my public key and you can verify it without having to know my private key. Why it's important is that some cryptocurrencies, it's like a Permian explosion, right? Like everybody's coming up with cryptocurrencies and they come up with their own schemes, and the old adage is don't roll your own crypto. And unfortunately, in this case, everybody's rolling their own crypto in different contexts, of course. But that's important. So please be careful. And thank you. And before you clap, okay, thank you. Please clap. This is going to be AMA. I think I might have spent maybe 20 minutes. So please raise your hand. I'm going to go back and forth from left and right. And then we're going to go gentleman there, who I happen to know.
Oh, hey. Thanks, hey. My name is Sid.
Yeah.
That was a great talk, by the way. Really learned a lot. Very, very enjoyable. And I had a question about proof of stake.
Yeah.
Where do you personally think the future of proof of stake is going?
This is like one where I get crucified. Where do I think? Well, okay. So in some cases, you want sort of cabal of people to act. In other cases, you want the rabble to be the one who's making the rules, right? But I think maybe I'm on the rabble side, and there's no hard and fast rule. But if I had to put my money on where I think is safer, I think it's there's the old saying that the law precedes legislation, and what that means is that the law exists by virtue of what people's expectations are prior to people actually writing down into a rule. And I think that also applies to cryptocurrency, where there's some expectation that, look, I don't want to get my money stolen, and I also I don't want anybody special writing the ledger of where I have the money, right? So in some cases, bank would be okay, I guess, but then in grand scheme of things, maybe you don't want to trust the banks. All right, let's have someone from this side, and then we'll go back and forth. So anybody here? All right, yes.
As far as scaling solutions go for blockchain technologies,
There you go.
As far as scaling solutions for blockchain technologies, because you can only, you can expand the block size through hard forking and everything, but with that comes the disadvantage of centralizing your
Sure.
the things going on behind the scenes. And so, in your opinion, what do you see the future of blockchain technology going in terms of scalability as it becomes more and more popular?
Right. So an interesting historical note is that in Satoshi Nakamoto's paper, he never mentions the word blockchain. So actually, that's one thing. He basically said history of transaction records. And going back to sort of, do you just increase the block size or not, right? And the question is like almost a religious dogmatic war in Bitcoin community. So I'll try to tread very carefully. And hopefully I don't get pilloried right after this. So thank you for asking that. Okay, so here's the first. So to put it into layman's term, because there are some new people here, what is a block? We covered that it's just a collection of records of transactions. A paid B this amount, B paid C this amount, and there's a timestamp of all these events, and then some signature that goes with the transactions, right? So in Bitcoin, it's limited to very small size, and you can only fit about a certain number of transactions before you have to create a new block in order to do that. But each time you create a new block, you have to solve for a new problem, right? So, and therefore, computationally, they're expensive, and therefore, it takes longer to verify your transaction. That's why you hear things like, well, it's been out there for 8 hours, and it still hasn't been, verified. What's going on? So the quick solution is to increase the block size and allow more transactions to fit in each block. And the reason why the blocks, the way that the blocks are created are the way they are is the following. You want ordered record of transactions, and in order to get to your ordered record of transactions, you need to have a singular solution for that particular set of transactions, meaning that someone is going to group transactions together first, and it has to be linear history. Like you can't have people like jumping in and say, well, I created $2, here you go, and just inflate the pot without following the rules of the game, right? So you need linear history, and that's what blocks are. In order to get to that point, if it takes longer to solve for a smaller block, then why don't you make the block huge and humongous? Now, there are two arguments against that. One is, as you scale up, it's not a long-term solution because you may have increased number of transactions that outpace the size of the blocks, and you have to keep increasing the size of the blocks. And two is that it probably will increase the size of the disk space requirement, but I mean that's sort of like debatable. So I'm not going to get to that argument because that's like saying you can't afford 2 extra SSDs, like whatever. So that's I think that's maybe that's not an interesting argument. So the question is, why do you want to have a smaller block versus big block? And the answer is this: so if you want a system where you have you want to slow down the transaction in order to ensure that the network is properly secured prior to transactions being validated, then maybe you want a smaller block. And it's entirely possible that that's a legitimate reason. But in the future, actually, if you follow Bitcoin core community, there are movements toward, okay, well, let's be more efficient about how the transaction records are stored so that you can decrease the size, because you pay fees on kilobytes and not on the amount of money. So let's say your transaction record is on half a kilobyte, then you only pay a fee on the kilobyte size. You don't pay on the amount of money that you send. So it's a very contentious point. So I'm gonna just kind of wave my hand and say leave it at that. But I'll talk to you more. But it's not a long-term solution.
I just had a question. Once this incentivized structure that blockchain is built, once that's gone, where's the whole industry going to go?
Oh yeah, so 2 questions. So one is sort of like, he who must not be named, which is Bitcoin. So if all the rewards are gone, who's gonna secure the network? And 2 is the what was the second part? Once it's all.
Once the incentivized structure is gone.
Oh right. So
everyone keeps going up on their market cap. Everyone keeps having.
Right. So if you miss the point, there's a final point that I made, which is that the only reason why Bitcoin is as secure as it is because there's a lot of money at stake, and therefore people who are creating mining farms on an industrial scale have vested interest to continue to mine and be a more or less honest player. And the other spammers, like me as an individual, will have a hard time defeating that security. And I'll cover that in a little bit. If it's not clear, let me know. So what if the price of Bitcoin goes to $100? Who will secure the network? The answer is the enthusiasts, number 1, and 2. Maybe at that price point, the transactions will. I don't know what the future holds. So maybe at that point, there will be better technology that handles bulk transactions better, like Lightning Network. Maybe there will be flowering of different kinds of cryptocurrency, and the computing power will have moved on to those different cryptocurrencies. I don't know. If I knew the future, I would not be here. Yes, sir.
Sort of a different question. I'm still trying to understand how, 5, 10, or 15 years from now, as a consumer, vendor, supplier, how the blockchain is going to make a difference. Am I still going to pay my PG&E bill the same way as I do today? Am I going to be buying a car and trusting a used car and trusting that, the previous 5 people did all the services that they needed to do, all that stuff? So.
Right. Okay, so that's a great question. Like, why are we even doing this? Where is the real life application? I mean, rather than just spinning up the wheel and calculating for some proof of work, why are we doing this? And the answer is that if it has anything to do with titles or something that requires neutral ground where everybody has to accept that the records are correct, then blockchain makes sense. So maybe like real estate, maybe like cars, like title records. Those things make sense to be on a public blockchain if our municipal governments ever get off their butts and maybe they can do something about it. But something like a power bill, that's a little bit suspect, but maybe the power exchanges can say, well, I bought this many kilowatts from some broker and then I sold it back to you at some other rate. Who knows? There is a blockchain for that. Unfortunately. Yes.
So I just want to go back to a few of them, but first regarding Bitcoin Core and Bitcoin Cash, you mentioned the hard fork versus another option.
Right.
I'm just curious if Bitcoin had a hard fork.
Sure. So what happened with Bitcoin Cash? Oh, jeez. It's okay. So I'll try to briefly summarize the history. So Bitcoin it has a history of debates about scaling, and one of them is bigger block size to put more transactions. The other is let's wait for better ways to handle transactions and scale it properly. Bitcoin Cash was the former, where let's just increase the block size, and Bitcoin Core has a very specific ways in which the improvement plans are carried out. Necessarily so, because there's a lot at stake. And so they have things like committees, Bitcoin improvement proposals, and all of that. The process in order to improve the code, come up with a proof of concept, validate that it works on testnet, and move forward. If you're impatient, there's nothing stopping you from forking the Bitcoin code and coming up with your own. And you've seen a gazillion of those. And so Bitcoin Cash is something similar, but except that it's one of the earlier groups that splintered off and said, okay, we want to play by different rules, and that's all it is.
But was there a hard fork to Bitcoin before?
Yeah, that's basically what it is. So whenever you have a separate set of rules, that's a hard fork. So if I send a transaction record, broadcast it over the network from and take from Bitcoin Cash network and broadcast it to Bitcoin network.
For example, when Mount Gox happened, was there a hard fork then because the network was compromised?
No. So that's two different problems. So I'll cover that. So one is that what happened to Mount Gox isn't the Bitcoin's problem. It's the centralization. So if someone had all your money in custody, because they have to have a centralized way to clear the transactions as quickly as possible, right? Then because of that centralized exchange holding your money, if they get hacked, then your money's gone. That's what it is. But that's not a problem with Bitcoin code, which is when I send you peer-to-peer, that's secure, right? Yeah. Oh, sorry. We'll go.
Great. Okay, worst case scenario. So the way I understand it, so every block is validated by somebody coming up with a string such that the hash comes out with a certain number of zeros at the end.
That's right.
Now, let's say somebody is super genius, and they're like, oh, I can start with the desired result and find the salt, the number I need to add to the block.
Yep.
The game over, right? Then
okay. So not quite. And the reason for that is that when you select a set of transaction records, you're lining them up in order, and then you collect them into a block, and you say, okay, I'm going to take this digest, push it through this function, and I want 6 or 60 zeros in the probe, right? That's actually a very difficult problem.
Are you certain?
Am I certain? No, I'm not a cryptographer.
That's my issue.
Okay.
Like, let's say somebody figures out how to reverse the hash.
Sure.
Given this number of zeros, oh, I know the salt.
Yeah. Well, it's not a salt. So
okay.
Not quite, because what you're doing is that the transaction records themselves are generated by everybody else, right? So it's not as though it's like a password where it's static and you remember exactly what it is. And because they are continuously being generated, and because everybody else is trying to solve for the same problem,
right.
So let's say that you created a false block, right? Let's say you constructed the record, put it together, and it looks legitimate, and you say, well, this is a solution because I know what the solution is. And you broadcast it, right?
Yeah.
What happens is then someone else has to verify it. They say, well, it's verified.
Yeah.
It gets added to the block. Then what happens? That's the question, right?
Right.
So what happens is the following. Because it's a forged block where you basically had to have known when someone sends you the transaction record, you have to have signed it, right? So when someone signs it, you have their signature with the transaction records, which is specific to them and the transaction record, which means that if you forged it and you come up with an arbitrary signature, at some point someone's going to say, this is bogus. This address doesn't have that. There's a way to verify the signature and basically say, this is bogus signature. I'm going to reject it. And so that block gets rejected and then everything else gets attached.
So it does not depend only on the hashing function.
Correct. There are other mechanisms where it makes it safe. Where, if you remember, it's tamper evident. 5 minutes, okay. Gentlemen over there, you've been waiting.
You said about there's a lot of money at stake because of the mining thing.
Sure.
So how do you differentiate a pre-mine tokens and the mine tokens?
Basically, pre-mine token says in the code that, well, this address is going to get this amount of token. It's pretty straightforward. And if you look at the commit hash and Git, their Git record, GitHub or whatever that they're using for version control, they'll say, well, here, you're just going to.
There is no proof of work.
Yeah. Well, no, there is a proof of work, but basically says that for this time period, no one else gets to contribute to mining effort, and that you get a lower difficulty. That's all it is.
Okay.
Yeah. Yes.
Thanks, James.
Yep.
So is there any exciting project that you're actually working on right now that you can share with us? And secondly, can you, so in my mind, like Maiden project is like similar to Lightning Network in terms of scalability for the Bitcoin.
Right.
Can you say more about Maiden project?
What?
Two questions.
Which project?
Maiden project.
Maiden project. I'm not familiar with that, but what I can say is there are different ways to scale different cryptocurrencies. So there is sort of like rule set that cryptocurrencies have at time 0, right? Like the 1.0 has certain rules, and that in order to get to next stage, they basically say, well, you can't have more than 10 million transactions at any given year without it slowing down. So then they have to scale. And there are different ways to scale it. One is on-chain scaling, which basically says you want to solve all the problems on-chain within the rule set that you have defined. And the second way is off-chain, where you basically say, well, I have lots of ways to have third party that basically can act as a escrow. So that's one way to do it. Or have a multi-sig wallet that basically acts as a clearinghouse and with a rule set on top of it. And there are other things like, well, why are we doing all these virtual machine calculations? Well, you can just get rid of it too, right? Yes?
Will you please comment on the introduction of financial futures on Bitcoin and its dramatic fall in price from $19,700 to less than $8,000?
I have no idea why that happened, so I can't really comment on it. If I knew, I would be a very wealthy man. Yes.
can you comment about the smart contracts on the Ethereum network and if that's present in Bitcoin and like kind of like the subtle differences between the two?
Sure. So Bitcoin has a scripting language called Script, very original. And Script is a very reduced set. It's not what's called Turing complete, which means that you can't write arbitrary code that does arbitrary things. It's very limited in what it can do. Whereas Ethereum has a Ethereum virtual machine where think of Ethereum as just a giant computational platform that just sits on and has you pay to play. That's basically what it is. And smart contract is just another name for a program that runs on this virtual machine. So think of it like, oh geez, what's an easy example? SETI at home. So you download the software, and then it runs on your machine, and then you send the result of that, the computation, right? So it has consistent rule, it sends you a chunk of work, and it's done. So that's the difference. So Bitcoin wants to be a basic building block where you build on the edge, and you have ways to build smart contracts outside of the network, and then integrate it back into the network.
That's the last question, Jay.
All right, yeah. I'm sorry.
Everyone, please put your hands together. So I just wanted to let everyone know that Jay's got 2 more sessions in this series, and the next one is Tuesday, the 27th of February in Palo Alto at Shepherd Mullen. So please come along because I know this has just whetted your appetite and you want more, right? This one was free as a trial, and the next one's like $10 a ticket. So if you jump in right now, you can get a $10 ticket and get all this incredible, valuable information from Jay.
Why don't you give us a free discount for the next session?
So next session is mainly going to be more fundamentals of what makes cryptocurrencies work. Some of the descriptions of the problem that I overlooked, like what is a Byzantine general's problem, and those sort of things, and double spending.
And you can read about what's in the second session on the event URL, and you can go to fintechsv.com to our calendar and you can read about that event. Thank you all so much for coming, really appreciate it.